It's an absolutely gorgeous day here at the Empire of Dirt headquarters, so why don't we try to use the newly fabricated cab tilt mechanism to see whether it actually tilts the cab. First we need to prepare a few things, but without further ramblings, let's get to it. Before we attempt to tilt the cab just out of the blue, it is good to know, or at least try to understand, what we're trying to achieve. So this might come to a surprise to a lot of people, but previous knowledge has been written down so that we don't have to figure it out by ourselves over and over. These things are called manuals. So this is the operating instruction booklet for the Unimog. So in here they've actually got, pictures and even some words on how to do this. And there's a few things that we need to prepare before we can just push the cab up into the air. So I'm now going to refresh my memory. And as you know, I have a very good memory. It is just a little bit short. In the engine bay, we need to unclip the cab heater hoses from this bracket, like that, like so. And then we need to take this hose off by removing or loosening this clamp here, which is what I'm going to do now. And that's all that's needed in the engine bay. In our Unimog we have the Atkinson Voss rubber mats, which are really great, but when we installed them we didn't really anticipate that we would lift the cab. So right here is a mark, and this is where the front bolt that holds the cab is. It's under there. So what we need to do is get a little knife and cut it open so we can access the bolt. Kaz managed to get access to the bolt at the front passenger side, and whilst she's working on the front driver's side, I'm going to undo these bolts. There's 4 of them in total, so as you've probably figured, 2 at the front and 2 at the back, 24mm. And don't leave these in the cab because they might fall and break the windscreen or something else. The next thing we're going to do is to put the hinge in place. These are probably seized up quite a bit, mainly because of the 1,000 layers of paint on it. Apparently this part has a propensity to rust, so apparently check that. This seems okay. Pull the pin out of there. Use some violence. Okay. No, I forgot. And the same procedure on the other side. The 4 bolts are removed inside the cab, so the cab is now just resting on there. This hinge is done. The other side is not really done because I think it's a bit skewed, so the moment we put a bit of pressure, I'm hoping that it'll slot into place. I just hope we will remember it. We put a strap on here, goes up to the hatch mechanism thingy there. We'll probably forget about this and then end up breaking the strap or the lifting device, but the point with that one is that we can adjust it so that we won't tilt the cab too far forward. We have checked inside the cab that there's nothing that is there that is loose and can damage any of the windows or anything else. We have got the air intake hose off and blocked on both ends. We've got the coolant pipes also off. And I believe that is now the time for us to start using the Fabricable cab tilt mechanism. Let's see how it goes. I'm trying to lift the cab tilt mechanism up into the cab mount. I think with hindsight this is not the best way to do it. It's probably better to hook it onto the chassis first and then let it balance there, and that way it'll require less force to get the tab for the cab mounted. If you are like me and your left and right hand switch side every 5.47 seconds, this is even more confusing than screwing in a bolt from the back. It took me several times to figure out which way I should turn the bars to get the tab to go forward or backwards. Eventually we got it aligned. Having someone to help you with this is definitely a huge benefit, especially if you're lazy like I am. The cab tilt is now installed. The bolt at the top there is fastened. The eyelet is on there, the chassis here. There's a bolt here to prevent it from falling out. So I believe that we are ready to start cranking and see if this actually works. It's finally time to start cranking. As a side note, it was 3 weeks and 3 days since I started building the cab tilt mechanism. Anywho, I started by using a regular 1/2 inch ratchet handle to crank the threaded bars. I'm doing this because I want to be able to feel any potential problems and movements that might happen. If I would just use the big Ooga Dooga with 1000 Newton meters, I would have no chance of prevent a failure. This way, I might be able to do something. What you're seeing here is the cranking bits from the lifting procedure. I've cut out all the times we've stopped and walked around to inspect everything. We checked the lifting mechanism, the hinges, any cables or hoses that might be attached. We checked the mounts and so forth. We're being extremely cautious and nervous. It took us about 1 hour to get it to the height we deemed okay. When you do the lifting, the heaviest load on the lifting mechanism is when you start the lift. Once the cab is tilted, more of the weight is being put on the hinges and the lifting gets easier. Eventually, we were happy to use the Ooga Dooga and the cab lifted easily. How much you decide to lift the cab is up to you. If you're going to lift the engine out, then you need to tilt the cab a lot more, maybe even close to 90 degrees. In our case, we just want access underneath, and we also want to be able to access the inside of the cab. Another piece of hindsight is that we should have positioned the rods so that the chassis rod would be far enough from the ground so that we could have put the Ooga Dooga in between the nut and the ground.
By turning the chassis rod, you push the connector piece, and thus you're making space between the ground and the nut on the chassis rod, so you don't have to have that rod close to the ground to start off with. Here's another angle of the lifting procedure. I wanted you to see this as it shows how we are constantly checking for any potential problems. If you do this, please do not stick any parts of your body, or anyone else's body for that matter, in between the chassis and the cab. It doesn't matter how much of a tough guy or gal you are, I doubt you'd be able to stop the cab if it goes into waffle maker position. Be careful. Once the cab is tilted, we need to make sure that it doesn't give in to gravity and change the angle we gave it. We are doing this by simply sticking these acro props in underneath the cab and wedging them into place. 2 of them, plus leaving the cab tilt mechanism in place, should be secure enough for us to reclaim the big kid's climbing frame, commonly known as the Unimog.
Now with the cab lifted and secured in 3 points, 2 of these on each side, and the actual cab lifty doohickey still attached, I can focus on making a proper prop, cab tilt prop, and I was told by the people who know more than me that it goes between the rear cab mount and the well, where the cab used to be mounted, so basically a stick between there. Now this moves, you know, because it's a Unimog, so the cab is attached to the front rigidly to the frame, and then because the frame can twist, but the cab shouldn't, this is where the motion of the ocean happens. So I need to make a stick that goes from that hole to that hole. Actually, I need to make 2 sticks, 1 on each side, because it moves, otherwise it would just be lying on one side, and that's not nice, is it? As we were running out of time last time we worked on this, i.e. the day when we propped it up, we didn't do much constructive filming. I had hoped to make the props that night, but that didn't happen. My intention was to make the props, and then I told Cass to just make a little panel to cover this up so we wouldn't get animals living in there or something. But we just ran out of time and things were more complicated than we had anticipated. Surprise, surprise. Anyway, what we managed to do was we cut up a piece of plywood, managed to slide it in through here and up to there. There's a little lip here, hopefully, or its job is to make sure that this doesn't slide down whilst you screw these in. Again, this is nothing more than a long screw, a piece of plywood, another piece of plywood, and they're just holding that in place here. It's actually quite sturdy. Annoyingly, there was a hole there, so I put a big bolt in it, the only one I could find. We put a tarp over the gear shifter and all that stuff so that it wouldn't get too wet and manky in the weather. But my progress on the prop ups was quite limited. Let me now show you what the revised prop up stick plan is compared to what I was going to do, and unfortunately I won't be able to do it as well as I had hoped I would do it, but I think it'll be good enough and at least improvable upon. Last time we worked on this, the plan for the prop up sticks was that I create a sleeve that I put the rear cab bolt into, and that then goes into the original mount here on the wiggly chassis member bit. And then I created a piece of metal with a hole in it, or I just drilled a hole, actually cut it to size. And my plan was that I would use one of the regular M16 bolts through this hole, and then I would put the nut on there, and that would then be attached up here where the bolt comes out of the cab. So it would be like that there. Hope you can see that. No, you can't. Like that. Yeah? So with those two bolted down, I could then take a prop-up stick and just simply weld them together. A bit of shaping and welding together, and that would mean that the prop-up stick would use the original mounts, which means that I can then work on anything else here without affecting the mounts that will be definitely needed. There is a mount right over there that you probably can't see, and then there's a hook on top of the cab. So for example, I could have made a prop-up stick there, but what happens if I then want to remove some of those components or change them? Then the prop-up stick would either be in the way, or I'd have to make a new one. Making a prop-up stick, or two in this case, that rely on the mounts that we already need and have to have, that means that they won't be that much in the way, and there is no danger of me screwing up their future function. Now, here's the problem. The eagle-eyed of you might notice that these are not the same length. Something I missed on that fateful evening whilst working on the German beast. And if we take the appropriate bolt, you'll see that the difference is even bigger. Now this one is the front cab mount bolt, this is the rear cab mount bolt, and this one is useless. In an ideal world now, I've figured out, I would use the front mount bolt in the bottom frame with appropriately sized spacer. This one is for the rear bolt, so I need to cut that down. And then I would use the rear cab bolt that lives there up there permanently to come out with its appropriate length from the hole there. And then instead of having a hole in this plate, I would have threaded this thread into this plate, which means that you just stick your hand into the cab and tighten this bolt, and it is there securely. Now the benefit of this is that I do not have to carry any extra hardware apart from the prop-up sticks. The front bolt is down and the rear bolt is up. Slight problem, especially now in these times. This here, if you can notice, is the bolt, and this one is a regular M16 bolt. Yes, the thread pitch is different. This is a fine thread bolt, this is a rough thread bolt, or ugly thread bolt, I don't know what the opposite is. So I can't get that. I can't get this thread either as a tap or a nut at the moment. If I had the nuts, I could simply weld on the nuts onto the sticky up stick or something like that, and it would be okay, but I can't get that. So to come up with a temporary solution, I have managed to find a threaded bar that is M16. So now I can make appropriately length bolts, not this one, but something that looks like this, and that means that I can make a bolt that comes out of there. I also have some nuts that I can weld onto this bit, or I can leave it without nuts. My point is that I can make a solution that whenever I find a proper tap or a set of proper bolt nuts, I can weld them onto there and then get on with that bit. And I think I've spoken about this enough now, so the next thing is to cut these down to fit the front bolts, make some bolts for up there, and then make a thingy to hold them, and then we will just take it from there. That's as far as my brain has managed to figure this one out. I now have my homemade bolt, which I need to put in from the inside to come out of that hole. And a word of warning, be very careful when you open the doors. They become quite heavy when they're angled this way, so carefully does it. So yeah, homemade bolt with the washer. Stick through there, spanner on in there. Here we go. My plate and the washer and the nut. Here we go. The squeeze, and that is now secured there. So now with the spacer at the bottom here and this one at the top, the plate, I just need to connect these two with a stick. I have now chamfered the fish mouthed a little bit this edge here. It's resting on a magnet there. There's a magnet thingy there. It looks fairly straight up to there. Another magnet there, and looks to be touching there. Had to adjust the cab a bit. I've also made sure that this one stays fairly horizontal, or at least in one position. There's a clamp on the other side is what I'm trying to say. Now the next thing I need to do is to add a little bit of hot metal glue there and some up there. Now when I have that done, I'm going to take it off, and then I'm going to make the other side the same as this one, which should hopefully guarantee that they take the load in a fairly similar manner. If I were to organically make this one and the other one at the same time, then I will probably end up with them welded in a different kind of position and different lengths and all that stuff, so this one wouldn't be parallel to that one, to the top there. So I hope that makes some form of sense. Anyway, hot metal glue next. Bzz, bzz, bzz. I've now bizzed together this one with a few more welds, so it's just one step above tack welded. But the thing I did after that is that I clamped the other pieces together, and then I ground the end here. Sorry for the noise for that bit. So now I'm going to clamp these together, well, as much as I can, and then hopefully I can make them as similar as possible. So clamping, and then more tack welds, and then hopefully fully welded. The second prop-up stick is now jigged, placed on the table. I started with putting that tube against this edge here, and making sure that this one is parallel to the table-ish. Then clamping the plate to the other plate and then spacing it up with these blocks, 5-bolt tool ones, magnetic ones, get them, they're great. And that means that if these two surfaces should be the same as these two surfaces, if that makes sense. Hopefully it does. So now I'm just gonna buzz it together quickly, and then I'm gonna try it on the Mog, and then I'm gonna stop pretending I'm this old Tony.
Before I start erasing all my welding mistakes and making it pretty, I thought it would be a good idea to actually try both of them in situ. So this is sort of how it's supposed to work. The bolt is spinning on the inside, but I think we can say that that works. And obviously it's not perfect, but it'll do. So, yeah, I think it's time to get the rotary eraser out, and then I'll be able to show this to other people. I really don't like removing old paint and powder coat from metal. I once spent a whole day getting rid of a small amount of powder coat using a regular flap disc. The powder coat just melted into the abrasive, and the end result was that I had several perfectly powder coated flap discs and a piece of metal with newly smeared powder coat on it. Since then I've discovered the polyabrasive disc. These are wonderful for removing paint, powder coat and surface rust. They don't gum up, and they are soft enough to not remove too much metal. The only downside is that they wear quite quickly, and that makes them a bit expensive, but they're so nice to use. Then, when most of the paint is gone, I go back with ye old classic flap disc and clean the metal to bling bling status. Finally, I cut off the excess metal using the cut-off disc. Then I grind it to shape it a little bit, and then I give it a once over with the flap disc as usual to make it all very pretty. Everything looked pretty blingy except for the insides of the tubes. The voices in my head told me that they would not be happy unless I cleaned that up. So I had to go get some small flap wheels and obey the voices.
And there's the shiny stick that I made, and there's the other shiny stick. I now need to paint them because they're gonna live outdoors for a while.
Much later.
As you might be able to see, the sticks now have a bit of paint on them, which hopefully should mean that they don't turn into rust immediately when I put them on the truck, which is outside. And you might hear that there's a lot of weather outside, so paint is probably a good idea. Without much further waffling on, I will put these on, take the temporary prop-up sticks off, and take the tilting mechanism off too, so that it can live indoors and have a happy life there.
Okay lads and lassies, hope you can hear me. The two sticks are now in, and I must say that the cab is surprisingly solid. It is very good. You can feel that it is moving in unison. There's no flex anywhere that is disconcerting in any way. So pretty pleased with that. Sadly, the actual lift has been outside for a few days, so it's got a little bit of surface rust on it because I didn't paint it, so maybe now's a good time to paint it.
I've lost count of how many times I've disassembled the cab tilt mechanism, but it does show how important it is to be able to take things apart. It might need repairing, maybe an enhancement, adjusting, or just a thorough cleaning. In other words, don't underestimate how important it is to be able to take your tools apart. Building them this way might take a little bit longer, but it's worth it in the end. During the lifting sequence, you might have noticed that the connector piece started turning around. This was less than ideal, and here I'm making an attempt at preventing that from happening. More about this in a little bit. Apart from a tiny bit of surface rust, all the parts were in good condition. All they needed was a quick brush off, and I'm trying these brushes with the red plastic bristles on them. They seem to work quite well. I've learned the hard way that paint only sticks to well-cleaned parts. I'm using some acetone to clean the parts off, just to give the paint a fair chance of sticking to them. Then it was time to spray a few coats of silver rim paint on the parts and leave them be for a while.
Apologies for the noise, weather, yeah. 2 days ago I put about 3 coats of paint on the parts, so now I see all the mistakes and inadequacies of my fabrication. Let's not talk about that. What I've just done is that I have used this big boy hairdryer to heat the parts up. And what that does is that it cures the paint quite quickly, and that means that they are a little bit more durable for my knocks and bangs when I'm going to assemble it all back together. It's not necessary to do. You could also leave it for a week or two for the chemicals to evaporate. Another thing you can do is you can put it in the oven. Put the oven to about 80 degrees C or something like that, and between every coat or after you've finished painting, you can put them in the oven for about 10 to 15, 20 minutes. There's no point in leaving them longer there. Once the chemicals have evaporated and the paint is hardened, it's hard. There's very little point in having it there for an hour or so. Anyway, at the moment they are still quite warm, and whilst they're warm, the paint is quite soft. So be a little bit careful with that, let them cool down properly. But yeah, heat them up so that they are not boiling, just they need to be warm, that's it. Next step is to assemble it all back once it's cooled down a bit. I wanted to do a little bit of an assembly recap and a bit of what I should have done differently. The first one is probably that this one is causing quite a bit of lever effect on this narrow bit here. So when the weight of the cab is on here, it causes this to squish quite hard against the threads. The solution to this would be to make this longer, either by spacing out the nuts that I welded or by adding more nuts, and more nuts means more binding, obviously. So could be made better, could also be made a lot worse. I've also welded on this nut here. It's a 24mm head nut, so it's the same as at the end of the threaded bars. As I already have 24mm nuts or tools available, I thought I'd use that. The purpose of this one is try to keep this thing aligned. I don't want it to twist when I lift the cab, and I had initially thought that I'd use an old socket, half-inch drive socket, so I could just put a breaker bar or something in here and then hold it steady. Anyway, it is to prevent it twisting. It's a 24mm socket, so I can just put any of the tools that I'm using to actually do the lifting on here. I haven't tried it yet, might not work. These two are only adjusted as well as they can be. They are jammed together, so that's the adjuster nut and that's the jam nut. As such, if they move together, the adjustment to bearings are not as it should be, or as you adjusted it. Therefore, I recommend that you check this somehow, some way, whenever you use the tool. Up at this end, again, this is the adjuster nut and this is the jam nut. However, on my design there is a pin through here, so this one shouldn't move that much, only within the pin itself. However, it's still good to check the adjustment of this every time you use it. When I built it, I forgot about this, that this nut here needed to be locked. My intention was to build one like this, i.e. just a bolt through at the top. However, I only remember that once I cut these to height. In hindsight, I should have cut them longer, and I should also have left the threaded bar nut bolt that I welded onto here longer, so I could have drilled through and secured it that way. In hindsight number 2, the pin is probably a more secure system when it comes from the adjustment perspective, i.e. the adjustment will vary less than this one, which has got about 2 or 3 threads that it can shift before the nut stops it. So that means that this one is here to prevent those nuts from falling off, and this one is here to prevent the nuts from falling off, but also a better adjuster. Obviously, again, keep these lubricated. I cut a little groove in here with the cutting disc so I could align these properly. By putting it here, there's only one way out of the 4 ways that this plate can fit. Otherwise the plate is just a plate with 3 holes in it. Make sure the bearings are well adjusted, make sure that they don't slip, make sure that there's lubrication. The chassis mount could have been longer. This one is pretty good actually. I'm quite surprised how well this one works, so pretty pleased with that one. Yeah. Apologies for my early morning appearance, but we did a 3D print last night after we got in from the workshop, so I'm very proud of Kaz. She designed this thing, and no, it's not what you think. Well, if you think it's for the Unimog, you're right, but if you think it's something else, then you're wrong. This is the first attempt. This is the first one we printed, and as usual with 3D printing, I tend to think as the first one as a definitive prototype, right? This is a, where are you? There. This is just a O-ring seal, and it should go on like this. Oh, guys. Anyway, it looks like it's a little bit too big, so I'll probably have to find a smaller one. Anyway, it is almost as it came off the printer. I have scraped the edge here with the knife just to get it a little bit nicer and softer, and then I have used my very nice file set, highly recommend these ones, to get rid of the support that we made so that it could have the groove here. We put a little bit of support in and basically just a little bit of things there. But let me get the pack of O-rings and let's fit a proper one, and then I'll show you where it actually goes. And no, it is not there unless you're thinking about the Unimog. Found a O-ring, seems to sit very well. This there is the front cab mount, and the idea of this one is, there we go, that'll keep the buggers out and the rain and whatever. So that's all it does, nothing more. And yeah, totally unnecessary.
But you know, us, had to be done.
Since the cab may be tilted for quite a while, and I don't really trust the duct tape that's currently sealing up the air filter and air filter hose, I decided it might be a good idea to make some plastic bungs to seal these. I spent a short time in Fusion 360 last night and modelled these up and printed them on a 3D printer. This one is designed to seal into the air filter hose and this one into the air filter. Let's see how they work. Well, that seems to fit pretty well.
This is where we'll wrap up this episode. I won't lower the cab because I need to get on with other stuff, but when you do lower the cab, the only thing that is different from reversal of the lifting procedure is that you need to align the steering column and put it on whilst lowering it. The operator's handbook says that you need a second person to do this, but I'm sure that if you spend enough energy you can do it yourself. You just get a lot of exercise doing it. One thing that we didn't film when we were starting the cab lift was that the left-hand hinge didn't go on immediately without any problems. I thought it was because the Unimog is not at perfect level ground and that sort of thing, so I thought that by lifting the cab we might actually be able to get it to align. Turns out that the hinge was misaligned, so if you experience this on either side, just undo the bolts and align the hinge and you're ready to go. No problem at all. Our version of the lift is by no means the ultimate final version. There are improvements to be made, and I'm grateful for the comments on the previous video that have pointed out a few things that could be made better. A simple one is to use a connector nut on the chassis mount, as this type of nut is approximately three times the length of a regular nut. Using one of those instead of two regular nuts would probably have avoided quite a lot of binding. Another one is to use the correct thread, not the regular bolt thread, but a trapezoidal thread. This is the type of thread that's used in vices and screw lift jacks and stuff like that. You can apparently buy threaded bars of those and nuts to go with them too, so you might as well use those if you want to make a better lift. Thank you to all of you who commented and suggested the improvements. It's much appreciated, and I hope future builds of this type of lift will make it even better. I hope you enjoyed this episode. Maybe you even found it a bit uplifting. Maybe you had a laugh, maybe you learned something. Either way, thank you ever so much for watching, and I hope to see you in the next episode of Unimog Shenanigans.